the symmetry and transformations class. Okay. We will be seeing symmetry, which you already know, line symmetry, but we will be adding another two types that we will see later on. Okay. Also transformations. Transformations are movements of figures. Okay. It can either be a rotation or just a translation. And we will see three different types. The types are reflection, when you have one object and reflect it to the other side. We have rotation, which is just moving it in a circular motion. And we have a translation, which is just moving it from one place to another without reflecting it. Okay? Those are the three types of transformations that we will be talking about today. And for them, we need to use symmetry. Okay? Let's define first a perpendicular bisector. Perpendicular bisector is a line that is perpendicular, meaning that it forms a 90-degree angle with the line that it intersects, and it intersects exactly on the midpoint of the segment. Okay? Let's say we have this line and we want to trace a bisector, a perpendicular bisector. We have to measure exactly the middle of this segment, which would be here, and then we have to make a line that is perpendicular, meaning that it forms a 90-degree angle with this segment. That would be a perpendicular bisector for this segment, okay? This is a perpendicular bisector for this segment. Now, a reflection, which is the first type of transformation that we will talk about, is a transformation in which each point is exactly at the same distance to the line of symmetry that we have. We can have a reflection of a point. Let's say this is point A, and this is our line of symmetry. Okay, it doesn't have to be straight. The line of symmetry can be horizontal, it can be vertical, or it can be diagonal. The characteristic is that the point is to the same distance of the line. Okay, if this distance is 10 centimeters, then the reflection of this point has to be 10 centimeters to the other side of the line. Okay? Reflection is as if we were looking through a mirror. Okay? This would be the reflection of point A. Okay? And it will be called A with a little apostrophe. Okay? Now we can also have a reflection of a line. If we have a line that goes, or a segment that goes from point A to point B, now point B also needs to be to the same distance that this point from the line. Okay? So let's say that point B is 15 centimeters from the axis, which is our symmetry line. So to the other side, point B also needs to be 15 centimeters away from the line. And it's going to be B with an apostrophe. Now we join the points and we have our symmetric segment. Okay? And if we have a figure, we are going to do the same. We are going to measure the distance of each point to the line of symmetry, and we need to have the same distance to the other side in order for the figure to be reflected. Okay? For reflection, we use a line of symmetry. Now, translations. A translation is just the movement of one point, line, figure from one place to the other without changing its direction. Okay? A reflection is, let's say my hand is the figure we are talking about. A reflection, we turn it around. Okay? It has the exact same measures, but it's the other side. Okay? In a translation, all we are going to do is move it. And how do we accomplish that using symmetry? We are going to do a double reflection. Okay? Let's say again that we have a point A and point B, and we are going to have a pair of parallel lines as our symmetry. Okay? This is one, and this is two. Okay? So we are going to do our first reflection having the same distance from point A to the line and from point B to the line. And we're going to have A apostrophe and B apostrophe. Okay? And then we are going to do another reflection of our reflection using the second line. And we're going to have the A double apostrophe and B double apostrophe. Okay? And as you can see, when we have double reflections, we have the segment in the same direction as the first. Okay? This is a translation. If we remove this that we have in the middle, we would see that the lines just moved from here to here without changing anything else other than its position. Now, a reflection is a rotation is reflecting the figure through a pair of intersecting lines. Okay? So first we are going to reflect it through one of these and then to another, and we are going to have a rotation as a result. And we are going to use the same principle. We are going to measure the distance between each of the points and our line of symmetry. We are going to measure the same distance to the other side. And then we are going to join our points. And we are going to do the same with the other axis. Okay, so we measure the distance to the line. We mark the same distance to the other side. we name the points, and we join them together with segments, and we have our rotation. Okay, the final figure that we get will be our rotation. Now you have skill check number 1 in your presentation. With this information you should be able to solve it. If you have any questions, you can log in to the Facebook Live Q&A. And then we have the types of symmetry. These types of symmetry are the ones that we have been using for making the transformations. Okay? But this time we are going to apply it to a single figure. Okay? We can say that one figure has a line of symmetry if we could trace that line, and the figure would be the same on both sides of that line. For example, circles. Circles have infinite lines of symmetry. Okay, we can trace any line in any point as long as it goes through the middle, and the circle is always going to be the same on both sides. Okay, we can trace a line in here, and this half is the same as this half. We can trace a line in here, and the upper half is the same as the lower half, and it doesn't matter where we trace the line, the circle is always going to be the same on both sides. We can also do a square. If we trace a line here, the square is the same on both sides. We can also trace a line here, and it's going to be the same. We can trace a line diagonally, and it's also a line of symmetry. Then we have rotational symmetry. If the figure, we can rotate it any number of degrees less than 360, and the figure would remain the same. We can apply the same thing to the square. If we rotate the square 90 degrees, it will remain the same figure. Okay, so a square also has rotational symmetry. And we can apply these to a rectangle, but a rectangle would have to be 180 degrees in order for us to have the same figure. Let's see, my tablet. If we rotate the tablet 180 degrees, it will have the same shape. Okay, we will not see any changes on the shape of the tablet. That means that the tablet has rotational symmetry. Okay. What else? Anything that you can rotate any amount of degrees less than 360 and it remains the same, it has a rotational symmetry. Okay. Now we also have point symmetry. Point symmetry is the same as rotational symmetry, except that it applies only for objects that rotated 180 degrees can be the same. Okay? An object can have both rotational and point symmetry, but it's not necessary that they have both. Okay? We can have an object that rotating it 120 degrees has symmetry, but rotating it 180, it doesn't, remains the same. So it would have rotational, but not point symmetry. Okay? So you have also skill check number 2, and this is about the types of symmetry. If you have any questions about it, don't forget to log in to the Facebook Live Q&A. That's it for this class. I hope you have a good day. Bye bye.